Just a little bit about us. Big Data Demystified is a community that it's been around for 4 years. Let me put my headphones. Can you hear me?
Yes, we can hear you.
Thank you. So Big Data Demystified is a community that's been around for 4 years. We're here to help the community. We talk about big data around the world, in Europe, in the US, in Israel. Most of the community started in Israel 4 years ago. And today is a continuation session about EMR Part 1. The content was uploaded to our website, bigdatademystified.ninja. The slides and video are already there. So unless you have questions about the previous sessions, we can start. No questions. Okay. So, hello everybody. My name is Omid. Today we are going to talk about the second session about EMR, AWS EMR. People are still joining as we speak, which is great, but I'm gonna continue our conversation and don't let this disrupt us so we can continue. So today's session is about other aspects of EMR you must master before you can do an effective job using EMR. Small disclaimer, I may not be the best in the world, but I really love what I do, so you're welcome to challenge me. Ask questions. Everything can turn into a discussion. You have my email, you have my LinkedIn, and you can engage with me before, during, after a session. You should know that there's lots of community groups specializing in AWS, in big data in general, BI and analytics. So we cover lots of grounds. A little bit about me. I work in various startups and some enterprises. So I've gathered quite a lot of use cases and quite a lot of experience using different technologies, different clouds, massive scale of data sets. So I've been around in quite some time playing with data. So you're welcome to challenge me because I'm really passionate about this. So the usual way I open these kind of sessions, I'm sorry, I'm looking to your right. The slides are on my right. I have 2 monitors here set up, so the camera is in front of me. In the past, we had 3-tier architecture where everything was simple, but then came big data and the infrastructure fell apart every now and then. Then came the cloud, which made everything much more complicated, and then the invoice that changed the way we think as architects. And it naturally keeps going because technology doesn't stop and wait for anyone. And my solution or approach to that is to apply big data methodologies and cloud methodologies, and that's the modern way of data engineering. Today's session is rather long in terms of slides because I made examples and visualizations for everything. But you're welcome to stop me at any time and ask questions. And if you're not speaking, please mute yourself so there won't be any disruptions on the video. But you're welcome to unmute yourself anytime and talk to me and make a discussions. Okay. Before I dig deeper, for those of you who just joined, any questions about the previous session? Just to be clear, we uploaded it to our website, Big Data Demystified. It's under Data Engineering, Amazon, AWS EMR, and you'll have AWS EMR Demystified Part 1. So if you want to catch up or review something, it's there. So let's talk. We have a very long session and we want to cover as much ground as possible. If needed, I'll break this session into two sessions and we'll continue in 2 weeks in part 3. It's on the 29th. So there shouldn't be 28, that is, sorry. So we can continue there. So we're going to talk about IAM. First thing you need to know about today's session, for EMR to work effectively, you need to understand that how to manage permission. You have two services. You have two concepts you need to know. IAM, which is Identity Access Management. I feel like I should stand. So 1 second, please. And I'm standing. So IAM is an Identity Access Management service by AWS. Sorry, there's a technical problem. One last try. Okay. So Identity Access Management is a service by AWS that allows you to manage services, identities. The identities could be either machines or humans, and we'll talk about that in a second. Before you understand how to manage identities, you need to understand the concept of identity management. And another important aspect is least privilege. Least privilege permission assumes that you give the least amount of permissions for a user instead of giving him admin permission. So you have identity access management, a user and a group and a role. A user is a single user that, for example, me, AWS user that has access key, secret key. It's like a complex password with 2 parts. And a group is simply a group of users, of single users, for example, R&D group with Omid Alter Ego 2 and Omid Alter Ego 3. I'm a rather complicated person, not my fault. And the third concept would be a role. A role is the same as single user, only temporary permissions assigned. You can apply it to an identity like AWS, Omid AWS user, same user from here. And I will get immediately a temporary access key secret key, or you can apply it to a machine. It doesn't matter how you set your identity, either via role, group, or a single user. Everything is attached to a permission set or a policy. For example, admin permissions on everything. Is this clear? Yes.
Sure. I have a question. So what's the difference between the single user and the group? So they kind of
So
same
a group is like in math. A group of single user is a group.
I understand. However, but here, so they are the different objects in AWS, right? So when you create, okay.
You can create a group and then assign users, and then immediately the users will get the group permissions.
Oh, got it. Thank you.
Thank you. Any more questions? June, if you can remove the hand signature or icon, it would be nice. Thank you. So let's continue. Sorry?
Can we have multiple groups in a group?
Yes. Inside the group, this I'm not sure. I never tried this. Let's assume for now, no. But maybe some feature exists that I'm not aware of.
Okay.
Thank you. Any more questions about this? So do you understand that a machine can have a set of permission even if it's temporary? So if I installed an EC2 machine, I want to give it access to S3, I can assign a role that has S3 permissions. How does that look? I can create an S3 read-only policy, which is a simple JSON file. That's how your policy would get, that allows S3 get operations and list operations, known as the plural, operations with an S, on any type of S3 resource. For example, this is something you can assign for an identity, meaning Omid can have read-only access to S3 buckets. However, you should know that you can do the other way around, meaning let the bucket determine also who can access it. Before I go deep into that, let's explain that a little bit by a graph. For example, by visualization. You have a user or a group or a role. For example, user with Amazon resource number 111, blah, 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 Omid. And I gave him S3 permissions to read write. So I can, and that user is me. So I can ask for permission for S3, but this is only one way. The other way around is that the resource itself can have a policy that says what he allows, he or it allows, actually. Let's take an example. For example, a resource-based policy on S3 would allow a principal named Omid, a principal is a user, action, for example, put only to write files on a specific resource, an S3 bucket. And I can have a condition which is basically public read. So essentially, in this example, I would ask a read-write example, but the bucket will only allow write operations. Is this clear? Questions before I proceed to the next session? Great. So the idea was to give you a little bit about permissions so you will be able to manage a very, very, very complex scenario where you do fine-grain access to EMR and you let it, for example, your EMR cluster will try to access a specific bucket and you will only allow this only if it's true, meaning you have different groups. One is assigned for the data and one is assigned for the analysis. And the user of the analysis group would like to analyze some data, but the DevOps team won't allow this because data governance issues. So this is useful in this kind of scenarios to understand these security and identity access management policies and resource-based policies. Okay, moving on to network. In a network, again, you need to understand a little bit of network if you want to become very efficient working with EMR. There's high-level concepts I assume you know, like AWS region, which is the data center, for example, in Virginia, which is the most popular, and availability zone, which is inside Virginia. You have three or five data centers, doesn't matter, which are geographically apart. For example, within Virginia, each data center has at least 25 kilometers from another availability zone, and they are connected via network. VPC is a simple virtual private center, which essentially means a network. Subnet, simple networking jargon for an IP address, whether it's public or private. We'll review that in a few seconds. And an endpoint and direct connect, we'll review that later. So in terms of regions, you should know that there's lots of regions around the world, in the US, in Europe, in Asia, and so on. A multi-AZ availability zone is what we discussed within a region. For example, US West 2 has two availability zones, which essentially imply two data centers which are geographically apart, at least 25 kilometers from each other. And each one of them has a VPC, which is spanning across the region, and public subnets, which is essentially a list of IP addresses which are accessible around the world. Okay? Any questions?
Why do we need a VPC? I didn't fully understand.
It's a simple networking feature. Every time you work with AWS, you essentially work in VPC. You don't always need to take care of it, but you need to understand that it exists, and your EMR will be working inside a VPC. Why is that important? We'll discuss that in a minute when we'll discuss endpoint and private and public subnets.
I understand. Thank you.
Welcome. So VPC, a little bit drilled down. So you have an AWS in general, and then you have an AWS region, which is a collection of regional data centers. And you have VPC, which is essentially a container for IP addresses. So you have subnets, right? So you have one subnet, which is 10.0.1.0, which is, all the 256 addresses instead of the last zero. Yeah. And you have another subnet, 10.0.2.0, which is another 256 sets of IP addresses. So essentially in availability zone 1 and availability zone 2, you can install 512 servers in this example. I hope this clarifies a little bit about subnets and availability zones. You should know, once you see the 10. Something notation, that usually implies a private IP. What's a private IP? It's an IP address like in your local area network, in your office, which is not accessible to the world. No one can SSH to that machine unless they are inside that network, or the same machine has a public IP address or a public subnet. So what's that? What you can see here for this example, this is a rather complicated example. Allow me to do this, maybe it will be easier. What you can see is, again, a VPC that spans the region. The orange is availability zone A and availability zone B. A router and an internet gateway, and this is the internet. So what you see here is an EC2 machines with two IP addresses. One is 172 dot something, which is private, and 203 dot something, which is public. So I can, from my office, can SSH directly through the gateway and the router to 203. This is the essential difference between private network and public network. You can assign both private and public to an instance, but the IP address may change based on your subnet and your availability zone. Is this clear? The concept of private versus public.
I try to think about development environment. Why can't I just do development environment instead of separating two public and private networks?
You can do that. You can do a lot of things. It's just options you can play with. And decision what to do when is an architectural decision. You should consult with your DevOps or architects to make a educated decision on what to do, when to do. But when approaching EMR, you should know that sometimes you will be given EMR addresses with private IP address, and then you need some sort of VPN access to that network, or you'll have public IP, and then all you have to do is open a port in the firewall, which is a security group we'll cover later.
We'll cover later about the use cases, yes?
In some, briefly more than others, but we can discuss anything you like. We can expand the discussion as much as needed.
Okay, interesting.
Okay. So, private and public subnets, we just discussed. I put 2 slides for that for some reason, but doesn't matter. So, once we are familiar with the public and private subnet, you should know that you can install EMR here, or you can install EMR here, but doesn't matter where you install it, you want to be able to access S3. So one way would be using the public gateway address, then it will go outside to the internet and access S3. Second one would be to use a service called S3 endpoint, which is essentially a gateway from the private instance or the private subnet internally in the internal network of AWS to an S3 bucket, which is more secure. Questions? Okay. A little bit about security. Now that we have a basic understanding of network and public and private separation, we need to talk about security. So there are 3 ways which are common, and you should know them to protect your EMR. One is security groups, which essentially is firewall rules. Bastion host, which is essentially a Linux machine you can SSH into because it's in the public subnet, and then from there you can access all other machines. And 3 types of encryptions: at rest, in motion, and in use. And we'll cover that in a second. So security group. In a test account, you have a VPC, and inside you have EC2 machines, but all of them are protected by security groups. As we discussed, it's essentially a firewall. So given a list of open ports, one can access those machines. For example, EMR can be accessed via port 22 or via SSH or via HTTP port 80. Is the concept clear? Okay. So EMR on a public subnet. EMR on a public subnet essentially means one thing. You have the AWS EMR service itself, which access via the internet into your VPC, into your cluster, which is also on a public subnet. You can open a port and make it accessible to the rest of the world for all the applications running there. If you want to be more secure, the recommended approach would be to put your cluster not on a private subnet, but rather on a private subnet with an S3 endpoint, and you will have a NAT service that will translate a public IP into your cluster. A more secure approach would be to use the same cluster only in private subnet and have a bastion host. So if you have a client machine, you can access via the internet, do an SSH to a bastion host, which has a public IP, and then another SSH to your private network, private subnet EMR cluster. And from there, you'll be able to access all your S3 data on S3 via the VPC. Questions?
It's like a it's like a middle layer between EMR cluster and the VPC.
Exactly. That's the whole architecture, security architecture. You put another layer between your client and your desired database.
Can it affect not the speed, I forgot the word, throughput, not throughput, the latency, because we have to access another layer during.
Yes, but it's not a layer that does compute. It's only a layer for access. So the latency is meaningless most of the time.
Mm-hmm. Okay.
Because when you do a command, it's running on the cluster itself, not on the bastion host. It's like a VPN tunnel. It slows you down, but not something you would notice normally.
Mm-hmm. Okay, but can it be also like a bottleneck if it acts like
Yes. Yes, because essentially this is a secure tunnel, which is encryption in motion, meaning all the traffic from here to the bastion host is encrypted. So every command you type is encrypted, and then it goes to here, and then you type again to here, so it's another SSH encryption.
So maybe it's irrelevant for real-time streaming.
It's not. It's not designed for real-time streaming. It's only designed for you to access your EMR cluster. It's not something you do in production workloads.
Understand.
Assuming you are an analyst and you want to access the EMR. Does this make sense for you?
Yeah.
Hi, Umit.
Okay.
I have a question. So,
Please.
is this Bastion host like edge node, you can say?
It's an EC2 machine with a Linux, standard Linux. You don't even have to install anything. It's just a methodology that you put an EC2 machine here, you SSH into it, and then from there you SSH into your cluster on a private network. That's it. That's to avoid giving a public, because what happens if I remove the public IP address from the EMR? I won't be able to access it. So I need some machine with a public IP address so I can SSH into it and then hop again to the private network.
Okay. Thank you.
I think there's a question in the chat. No, yes, we can. Someone asked something, someone answered. Great. You're more than welcome to use the chat, by the way, to ask questions. Feel free. Okay, let's continue. Other security measures which are just as important, keeper. You can use a key to access your EMR clusters like any other EC2 machine, but you can choose not to use keeper, meaning the cluster will be highly secure because you won't be able to access it. Only let it run automatically via steps. You can use EMR security configurations, which essentially allows you complex security settings, which are more encryptions and so on and so forth. Any questions about security before we continue? Great. So a little bit about instance types, tips, and tricks, because when you install an EMR cluster, you usually need to choose your instance type. So the relevant jargon for these sessions is you need to understand a CPU core versus a CPU virtual core. You need to understand multi-threading and Spark executor, throughput versus latency, transit versus 24/7 clusters, auto-scaling and scaling in and out. So we're going to cover that. So for simplicity, I created some visualizations. A physical CPU is simple hardware like Intel chip or AMD. We have a physical hardware inside. There are 4 cores. An optimization trick by hardware would be called hyperthreading, which essentially tricks the OS into thinking it has virtual CPUs, double the amount, meaning a 4-core CPU will transform into an 8-core virtual CPU. So when you are choosing a server with 8 vCPUs, you are essentially choosing 4-core physical server, which is okay for all intended purposes of EMR processing. This is very good. Why is that very good? Because this hyperthreading optimization trick allows you to minimize CPU wait time. So essentially, you are benefiting from the vCPUs as if you have double the amount of horsepower. Any questions about this? Okay, let me mute some notifications before I continue. Thank you very much. Okay, so how does EMR work? Once you have a Spark job, you have the Spark essentially fires some executors, which are each executor can be assigned several CPUs and several RAM. But for example, let's do a 1-to-1 correlation. Executor 1 is firing 1 CPU, and it's correlated like this. So essentially, a Spark job can take, in this example, 50% of our CPU and vCPU in the cluster. So it's quite similar to multi-threading. So if you know to write an application that uses 4 cores out of 8, then essentially you're doing multi-threading. So while working with Spark, you're essentially doing multi-threading very easy. Is this slide clear? Great. So I'm going to mute those who are unmuted for now because I can hear voices, which is bugging the recording. But feel free to unmute yourself should you wish. Okay, latency versus throughput. So more people don't know the difference between latency and throughput, and this is important. Basically, if you did, this is the time access. Latency is the time that passes from the moment you request a thread to start until it actually starts to work. This latency is wait time which is wasted. Only when you get the thread from the CPU, from the operating system, then you start measuring throughput. How much data, for example, was processed in milliseconds. Questions? Okay. So, for example, if you have several jobs running on your CPU core, and you have only one core and you have two jobs, and the operating system will manage it for you by a round-robin algorithm, which is essentially splitting the time between job 1 and job 2. Oops. Okay? Great. So, there are two types of instances in AWS that you should remember. They are compute optimized, which are quite few, but they start with the letter C, and each of them has a size. For example, this one, C7G extra large, which has 4 vCPUs and 8 gigabytes of RAM, can sustain up to 12.5 gigabytes per second. And there are other types of machines, we don't need one, which are memory optimized. Let's open those. They start with the letter R and also has a size. For example, let's compare extra large, 4 CPUs and 8 gigabytes, that 1:2 ratio. Extra large, 4 CPUs, you can see that it has 32 gigs, which is 1:8 ratio. And why is that important? Can anyone think of a reason?
No.
Anyone? Okay, so essentially some jobs require more memory and some jobs require more CPU response time, meaning they need to work faster. So this will be faster, but this will make the job finish if it's lots of data, for example. You should know that it doesn't matter which instance you choose, there's always an overhead. Why is there an overhead? For example, you have 10 CPU cores, at least one will be for the operating system, and at least one will be for the storage and network. So essentially, a 10 CPU machine will essentially mean that most of the time you'll have 8 CPU cores available for you. And the same goes for RAM. If you think you have 128 gigabytes of free RAM, you should know when working with EMR that the operating system takes a little bit of memory. The Java virtual machine also takes a little bit of memory, and the Yarn, which is this resource manager service of EMR, also takes a little bit of memory. So essentially, it reduces the amount of memory to 50% of what you're selecting. This is why it's usually good decision to start with the R instances for EMR. Another thing to know that there's a network overhead. Why is that? Because when you use Hadoop file system and you use S3 as well, and sometimes there's over here a job trying to run on these 3 machines, and the data is here on the orange, but it requires a job, requires data from this machine, which is unavailable for compute. So the data would start moving here to these 3 machines, therefore slowing everything down. So if you take 4 small machines and you take one machine, which is 4 times bigger, the bandwidth will be bigger and you'll have less overhead of network shuffling. Is this slide clear? Questions, anyone, please?
Yes.
No one? Okay. So the next session will be about storage application types. There's a couple of jargon you should know when we speak about storage. One, there's a kernel space file system, which is, for example, ext4, XFS. It's not going to be covered in depth today, but it's usually what you have on every computer. It doesn't matter if it's a laptop or a server. And there's a user space file system, which is, this kernel space is part of the operating system usually. So you don't need to manage it or think about it too much. But there's a user space file system, which is essentially an application running on top of your operating system. For example, Hadoop file system. And there's an object storage, which, for example, S3, which is a storage layer, and it has a different architecture, and we'll review that. High availability, disaster recovery, concurrency, throughput, and latency. So let's talk about the file system a little bit. It's a bit advanced, so if you don't get it, it's not really important, but usually a file system is local to one machine. It's usually not fault tolerant, meaning you can create a hardware-based fault tolerance or by RAID, by combining 2 disks and mirror the data, but it's not relevant for EMR. Some of the file systems are designed for throughput, some are designed for concurrency or parallelism. For example, these are the main 2 differences for XFS and EXT. This can affect your performances on data center deployments, but again, not relevant for EMR. Some file systems have a maximum supported size, for example, 16 terabyte per partition of ext4. So it becomes very complex how you manage big data storage system, or for example, 1 petabyte on local file system, which physically not possible. File system tuning is non-trivial, and most common file systems are not parallel. So they only work like one single thread application. There are paid file systems you can buy, like general purpose file system by IBM, which is parallel, and it's very useful to store any amount of data you want and to work in parallel. It's very powerful. This is a sign note just to tell you why is it so complicated to use a file system on data center, and why EMR basically simplifies your life. So let's talk about that. When you talk about Hadoop, you have Hadoop file system. So what's a Hadoop file system? We mentioned that a couple of times. Now we're going to go in depth. So we talked about the fact that it's a user space file system, meaning in its application. And like any application, it has a design. And it has pros and cons and architecture and services running and monitoring and tuning and so on and so forth. So why is it good for? It's a parallel file system, meaning each disk can work in parallel and it's separate with the others. It's not relevant to the other disk. It can work by its own. This point clear, because we're going to base our conversation on this. Okay. So it's petascale supported, meaning you can support as much data as you need on an Hadoop file system. And it's highly customizable and it's very scalable. It's decoupled from your compute. You can only save the data on HDFS. There's no processing. The processing is done by the compute. If you remember the architecture of Hadoop, talked about compute, storage, and resource management. So it's decoupled from the compute, and it's essentially designed for data center architecture. It has a rack-aware design, meaning it knows which server it's running in, and you can configure proximity of servers to give a priority. But most people don't know what's a rack, so let's keep it for now, not relevant for EMR. It's fault tolerant, meaning it's designed to fail and recover. Cons, it's not cloud native. It didn't have cloud design in mind. It's a non-trivial rebalancing. Rebalancing is when a data node fails, what happens with the data. We'll cover that later. One second, please. One second. So essentially it's hard to configure and maintenance, but the cluster is always as strong as your weakest node. Because what happens in HDFL file system, it's distributed on many servers, and over time when you run out of storage, you just add more servers. But all HDFS deployments can span up to 10, 20 years. That means you have a machine which is 10-year-old and it's very weak compared with the newest server. So it would create a bottleneck. So it's not a cloud native design. It's double. And you should know that if you want to provide an SLA, service level agreement, which is excellent, it's very expensive. You cannot do a trivial disaster recovery. It's very old school file system and it has non-trivial data governance. Any questions about what is HDFS before we go into examples? Okay. So essentially, if I demystify it, simply put, a user can request a file or put a file into HDFS. It's a simple API request, get, put. And your application will either receive a file and save it to disk, or give you a file. So if we talk about the architecture, you have an EMR architecture which consists of the resource management, compute, and storage. And we said in EMR you have a master node, which doesn't have HDFS installed, but it has applications like Jupyter, a core node, which has an HDFS file system, and a task node, which has no HDFS. It's only compute. And you have an external storage file system, which is S3. Any questions about the architecture before we proceed? Because there's lots of examples based on this slide. Okay. So let's talk about EMR with HDFS architecture. You have a name node, which is an application that manages all the files location on HDFS, meaning when a job comes, it asks the master node, listen, I want to run a job or a specific file, where is it? So listen, core node A will have your files, go ahead. So you have additional task node that the job can utilize to access the data here on HDFS. So essentially there will be shuffling of data from core nodes to task node to compute, to assume the compute. So essentially, if you have a 3 core node deployment cluster, HDFS will span about these 3 servers in the cluster. And the name node will be in constant communication with each of the core nodes, back and forth about the status of each core node. Why is that? Let's talk about it in a second. Naturally, you can understand that if you have a name node and you must have active passive deployment, meaning a high availability deployment to protect your file system, because if your name node will fail, you lose the references to your entire file system. So essentially you can delete the cluster because nobody will know where are the files located anymore. So if you have a very large cluster with petabyte and it has to be 24/7 available, so make sure your master node has 2 nodes, not 1 node, because if this will be lost, everything will be lost, all your files. Is this issue clear?
We can also manage our resources via EKS, isn't it?
Forget EKS for the sake of the discussion, for today's discussion. This complicates everything by order of magnitude, but yes, the answer is yes.
I understand. Okay.
For simplicity, we're going to focus only on EMR. Today, EKS is another managed service for Kubernetes. So let's talk about why is HDFS fault tolerant. Let's demystify it. By design, HDFS has a replication factor feature, meaning each file is replicated at least 2 times. You can set the replication factor to any number you wish, but it will multiply your data. For example, if you have 1 file, for example, D1A, it will be replicated twice. So if it's 1 gigabyte, then you will have 2 gigabytes on your cluster. But the reason for that is because if node A will be lost, you will have a copy on node B. So it's the job of the Hadoop file system that any file being written to HDFS will be replicated at least twice. Questions? Okay. So what happens if you lose a node? You essentially lose the disk as well because they are no longer accessible because there's no OS to manage those disks. So the Hadoop file system will transfer, will ask the name node what files are lost, and it will tell them D1C, and it will copy his body to another machine, meaning if the green part here is the copy of the green part here, the green part will be replicated now to node B to make sure the data is fault tolerant. Same goes for the purple, which was lost. The purple from here will be replicated to node B. This is essentially a rebalancing in a core node failure scenario. So what happens when you scale in and out? For example, let's take a simple scenario. When you add, you have a two core node scenario, A and B, and you want to add another core node. It's scale out scenario. It's a trivial scenario in cloud, but when you have HDFS will automatically understand there's a new server, and now it will attempt to rebalance the data on three machines. So the green part will now be replicated to node C, and the purple will be replicated to C, and it will be rebalanced on the entire cluster. But this operation is very expensive in terms of network. For example, imagine these three nodes, core nodes, have 30 terabytes. And that means 10 terabytes were copied from A to 5 terabytes were copied from A to C, and another 5 from B to C. So each of the nodes will have 10 terabytes and a total of 30 instead of 15 here and 15 here originally. Is this scenario clear? Okay. So let's complicate it a little bit. So you have a 3 core node scenario. You have 3 jobs running sequentially, one after another. The first job fails because only the disk in core node C has failed. It has another copy, but the job has failed because it tried to access the disk which no longer exists. So they throws an exception and retries. So the retry will work 50% slower because now there's only one copy of the file, not two. So only one machine can answer the job, not two. It will continue working, but it will finish while job 3 runs in an optimal state because two machines, B and C, can provide answers for the job in terms of data. This is essentially a concurrency scenario where you have a couple of jobs running and the amount of disk and the amount of cores impacts them and your ability to answer the end users. Questions before I continue? Okay. So best practices. So always have at least 2 replication factors. You can set it to 3, which is also a common practice in some use cases, but naturally you will be saving 3 times the amount of data you expect. And you need more machines for that, meaning you need at least 3 machines. Never, ever, ever, ever keep one master node when you have a 20/7 cluster, because if your master node fails, the entire cluster will be lost. If you are designing an HDFS, design the amount of disk to support the estimated amount of concurrency. Meaning the more disk you have, the more concurrency you will be able to serve. Always consider what happens in case of a node failure and how it will impact you. Use task nodes as much as possible to minimize HDFL nodes, meaning minimize core nodes. In the cloud, you should avoid HDFS as much as possible. However, there are some use cases there where it makes sense. For example, temporary storage for a job, or you want to avoid a round trip time from S3, which we'll discuss later on when we discuss working with S3 and EMR. Fault tolerant is excellent, but service level agreement is costly. So you might want to consider working with S3. 4 level notes about EMR HDFS. So if you remember the HDFS cluster from before, in each machine, for each partition, there will be a file system which is managed by the system. It will usually be ext4, but in some extreme cases where you want to do concurrency, XFS might improve your performance. This is a rather side note. You don't have to remember this. S3. S3 is essentially quite similar to the purpose of a storage solution in the EMR ecosystem. So like HDFS, you can do two operations, put and get. I mean, give me a file or get a file. So one would ask, so what's the difference from HDFS if it's more or less the same? So here's the thing. One, the architecture is different. It's designed by an object storage architecture, which is a traditional storage system architecture, which has its pros and its cons like any other application, because essentially S3 is an application which is designed to support storage use cases, but still an application. So it's a managed service, meaning AWS will manage the disks for you, which is very nice. It's supported for multi-petabyte easily. It's highly secure, seamless, and scalability. You don't have to worry about disk failure. And it has a scalable throughput for objects. It's truly decoupled from your compute. Not like in a core node where the compute and the storage are in the same machine. So you can go separately on the compute and go separately on your storage system. It's a cloud native architecture designed for cloud from the start. And you have high availability and disaster recovery in a click. And it's fault tolerant, and it has fine-grained security access, and you can do easy data governance, and you have a replication factor of 3 by default. The cons: round trip time to EMR is network-based, so you need to go from EMR to S3 back and forth, and it's essentially wasted time in your job compared with HDFS, where the files are local. Metadata operations suffer from a penalty, so we'll discuss that later. You need to consider minimal file size for billing and for performance tuning, and throughput is now correlated to the amount of machines you have in the cluster. So let's talk about object storage architecture. Essentially, you have many users accessing storage gateway in the same time. But behind the scenes, you have 2 main services. One, object servers, which essentially hold the data, the files, and metadata servers, which are only holding the metadata of an object. For example, file is here, but the file name, file, created date, and last update, and the file size are stored here. So essentially, if you're doing an ls operation, a list, you will be accessing the metadata. But if you are doing put and get, you're accessing the files back and forth. Questions? Comments? Something? Okay. So using the previous visualization, you have disks, and you have empty disks, and used disks, and you have a replication factor of 3, not 2, as it were, for simplicity. But you don't need to worry about this, because essentially you are talking with the gateway. So it would look like this. You have an S3 storage system, which is globally distributed in every continent. So you can have your data replicated anywhere you like in a click. The problem with S3 is RTT time, round trip time, meaning from your EMR cluster back and forth, because your bottleneck becomes not the disk speed, but rather your network bandwidth. So if you are using a public network, you have the bottleneck of going through the internet from EMR to S3, back and forth, back and forth. If you are using the S3 endpoint, you have RTT time from the private network back and forth to your private instance to make it faster, or using the web. Naturally, RTT time on private network will be more secure and faster. Questions about this? Okay. 401, 11 notes about S3. Okay. Truly decoupled. What happens if you have a small EMR but very large number of buckets? Everything will be the same because it's truly decoupled. S3 doesn't mind how big is your cluster, and EMR doesn't mind how many buckets you have. So what happens if I have multiple computes in one bucket? The same. It's totally decoupled. You can have several computes on EMR like Hive, Spark, and Presto, all accessing in your bucket, your one bucket. So you don't have to have a replica of your data for Presto and another replica for Spark and another replica for Hive. You essentially work with the data lake, and you can access your data from any storage layer, Azure Blob, S3, GCS, which is Google Cloud Storage, and so on and so forth. Questions about S3 before I move forward?
Yeah, I have one question. So you mean for one job, it doesn't matter if we have create one bucket or create multiple S3 bucket for it, right?
I didn't understand your question.
Yeah, just for a job, right? For we have a job, so we could use multiple S3 buckets. We can also use one single S3 bucket. So based on what you said, it doesn't really matter, right? There's no big difference.
It's no big difference. It's only what is good for you, because sometimes you want to separate data sources for different buckets. And sometimes you want to put them in one to protect them the same way in terms of resource policy, if you remember from the beginning of the session. Because imagine you have lots of buckets, and each bucket you want to give the same policy. So it's a duplicate policy you need to publish for each bucket.
Got it. Thanks.
You're welcome. Any more questions before I proceed? Okay. So let's see where are we? We're in good progress. Yes. So storage format. It gets a bit confusing in this part because people confuse a storage layer and a storage format. A storage format is essentially a format of a file. Well, a storage layer is an application that handles storage use case. This means if, for example, you know a structured storage format like CSV, comma separated values, or TSV, which is tab separated values, it's a simple text file. You also know semi-structured storage formats like JSON, XML, and log files. Also, again, text files. But some people don't know that there are binary formats, which could be structured or semi-structured. For example, Avro, Parquet, Oak, Delta Lake, Iceberg, and so on and so forth. So what's a binary file format? It's a file format that you cannot open in a text editor, but you can open in a specialized software. A software that complies with the Parquet standard, or the Avro standard, or the Oak standard. It's a storage format which is a simple spec, publicly available, that anyone can access and implement a connector to such a storage format. So this is essentially what makes an Hadoop ecosystem very powerful, because every bit of technology, for example, PrestaSpark Hive, can now access S3 via the coupled storage layer, and any type of these formats, because all of these technologies have agreed to support these storage formats. So they can all read and write CSV, TSV, JSON, XML logs, but they specialize in Avro, Parquet, or Delta Lake, and Apache Iceberg, which keeps growing and keeps being improved. For example, Delta Lake and Icebergs are developments of the last few years. And it gets more trickier. Why? Because it doesn't matter which file format it is, you can compress it. And why you want to compress a file? You want to compress a file because it will take less disk space. For example, 1 terabyte of CSV file, if you use gzip compression, will take about 1 terabyte, it will become 200 gigabytes on your S3. So why is that important? Because if you have a visual example here for the internet, a text file with 585 gigabytes, forget the RC file format, in Parquet will be compressed to 221, and in Oak will be compressed to 131 gigabytes. So why is that important? Because this will be essentially 5 times cheaper to save on S3. So one would ask, so what about the compute? Storage is clear. What about the processing time? Because you need to decompress and compress. Decompress to open the file, process it, and compress back when you write back to S3. So this is essentially where it gets tricky, but in the end of the day, compression is worth your time. and because it will minimize the round trip time from S3 back and forward. So essentially, this will work 5 times faster if you spend on a job that requires 1 terabyte of data from your S3 bucket.
Or C file is also have
Yes.
has schema like
Yes. 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 And they are both columnar, both Parquet and org. You should know that Avro is row-based and Parquet and org are columnar.
Okay.
If you're not sure which storage format to use, as a rule of thumb, use Parquet and gzip. Why use another compression? Because each compression may compress more or less based on your data, because they have different algorithms for compression. What's a compression? It's like a zip in your computer. So essentially, the better your algorithm you have for compression, the less disk space you will use, and the most effective you will be in your job processing. Questions? Okay. So when should you use Avro or Parquet? As I mentioned a minute ago, Avro is robust. When you have a semi-structured data format, which is highly nested, sometimes it will be faster to read a row instead of a whole column in Parquet. But if you are unsure and you don't know your use case, you don't know what type of queries will run more efficiently, simply use Parquet and gzip compression. But if you want to go experiment org versus Parquet, org has some optimizations regarding join. This is rather complex to know this and to manage it, so I usually don't recommend people to use org. But you should know that in some extreme cases, processing the same data via org would be much faster and could be more compressed. Once you should use compression, you should know that I did quite a similar test to this one when someone took 203 megabyte uncompressed and used different algorithms to compress them, and then measured the time for compression and decompression. And you can see, for example, that besides the compression size, forget that it was shrink to 40%, okay? You can see that the compression time is highly differentiated, and the decompress time is also highly differentiated. So essentially what you have is compression speed of 18 megabytes per second in gzip instead of 2.4 in bzip2. So this is why I told you use gzip as a rule of thumb. The same goes for decompression megabytes per second, 61 instead of 12, and so on and so forth. Okay? But why should you consider others? Because, for example, bzip generated less footprint on your disk space. So it really depends what you're trying to achieve. Okay? Questions about compression before I continue?
Yes, about the when do we use the I mean, at what level? If we have like Avro file or Parquet file or org file, we have to compress it and then store it as a compressed file in S3?
Yes, and then your compute, if you use Hadoop, will automatically be able to decompress and compress it automatically for you without any further, just give it a compressed file and Spark will handle it. The same way it will handle any uncompressed file.
But if I'm talking about event data, which is relatively small, but I have a lot of
Always aggregate, not aggregate, gather your data into one of those storage formats we discussed. Always. Doesn't matter if you have one event in JSON every second. Always do a daily, nightly job. We'll gather all your JSON and combine them into one Parquet file.
Okay.
Okay. Questions? So there are lots of comparisons you can do around the storage format, but the main things are about schema evolution, the schema changes. Each of these file formats can contain the schema inside the file. So it makes it very easy to analyze and compute. And it may affect the compression and splittability. And it's always a matter of which platform are compatible with this storage format. Nowadays, these top three are very familiar and very well known. And you should know only the difference of row versus column and schema evolution. And you should know that some of them are write optimized and some of them are read optimized. In the end of the day, the differences are not something that would benefit in most use cases, and you should simply use Parquet. When should you use a text file? There's only one scenario you should use a text file, when you're too lazy to move JSON file into a Parquet or Avro, or when compression is everything. This is a tip I give only to community members, which is very cost saving. So don't go ahead and spread the rumor, but you should know that a text file of CSV compressed in gzip is probably the most compressed file you will find in any other format. Meaning 1 terabyte uncompressed of CSV. If you compress it, you will have, let's say, 150 gigabytes, while in the rest of the storage solutions, you'll get around 200 gigabytes. So in the end of the day, if compression footprint on S3 is what matters most, and billing in the end of the month is what matters most, you should consider using a text file format like CSV and gzip. Questions? Okay. When should we use our Iceberg? Iceberg is a storage format relatively new compared to Hadoop ecosystem. We created a blog here when you use Athena. Essentially, Iceberg is a storage format that allows you ACID operations. And it's very detailed in this blog, but for example, you can do alter table, which is not something you can do in any other storage format. You can do delete column. You can rename a column, which is very nice. And you need to do the overhead is doing operational maintenance commands like optimizing your table. And if you're using Athena, it will be worth your while considering it because the setup is quite simple. All you have to do is add this table properties, table type, iceberg, and run every now and then your optimization. Questions about iceberg? Okay. Partition types. Let's see how close we are to the end. 10 more slides, bear with me. Essentially speaking, you should always consider the following format. DT, which is datetime, equals the date, is a folder name inside your bucket. This will essentially tell the Hadoop ecosystem that you have a partition, which is the name is DT, and the value is this date. So instead of saving 1 second for the question in the audience, instead of saving duplicate columns for dates for each file, you can use partition for that. Question in the audience, what is the difference between iceberg and Parquet? Essentially, both will do the same with a major difference. But as I showed here, Athena Iceberg is a storage format that allows you ACID operations. You cannot do that in Parquet. The schema is fixed per file. You cannot change it once you use Parquet. Once you use Parquet, you cannot change it. But once you use Iceberg and you want to add a column, you can do that. That's the biggest major difference. Generally speaking, managing Parquet partition is non-trivial. Why? Because too much partition will result in poor performance. Too little partitions will also result in poor performance and even high costs. There are ways to manage partitions, but this is out of scope for this course. As a rule of thumb, keep a partition per day and you should be okay. Drone, you have a question?
Yeah, I also wrote it in the chat. I mean, what about the differences between Delta Live tables versus Iceberg, actually? Both these formats.
This is out of scope for today's session, but essentially Iceberg and Delta are the same concept. Schema evolution and ACID
they both
operations.
support a ACID cause. So I was confused, actually.
ACID is atomic consistency, interoperability, and durability, meaning it will be more consistent and you can do update and delete and alter table and operations like that.
So when to go with which one, the Iceberg or Delta Live?
Essentially, Delta, I would go when you use Databricks. Iceberg when you use EMR. That's a general rule of thumb, not a very detailed explanation why.
Okay.
Another question from the chat. Thanks. Had the impression that Iceberg is used to manage schema evolution for other formats. Yes, I'm not going to go too deep into that because it's a bit confusing, but essentially differentiate in your mind storage format because it will be easier to understand. Okay? I hope this answers your questions, Andre. Okay. Generally speaking, on partition, once you feel comfortable to experiment with that, you should experiment and understand the impact on your job, because it's very important to design your partitions effectively. Summary. We did it, guys. 83 slides. Open your mics and let's talk. Why did we learn this session today? Why we did this long tour about network, security, storage formats, S3 architecture, HDFS architecture? What do you think? Would you like to have an open discussion about this?
I think it's part of designing a more complex architecture when it's more mature and have to serve lots of users. But I think it's kind of the practices that you have to use to implement after some time from, or maybe when you design, during designing your application.
Right, you are. Anyone want to add to the conversation? As Aviv said, yes, you need to understand all the different aspects of EMR to effectively design an EMR cluster, because in the end of the day, you want to make your jobs run faster and cheaper and simpler, because you want to minimize maintenance, you want to minimize costs, and you want the job to run as fast as possible. And using an EMR, it becomes very easy to make a mistake, not because of EMR, because the back-end technology, which is Hadoop, it's highly complex. So what would make your EMR faster? This is an open question. Would you like to comment, share what you understood from today's session?
Maybe choosing the right machines for each use case. For instance, for computing optimized, or for the memory operation, more memory optimized.
Right, you are. And what about S3 versus HDFS? What would be faster?
I already learned that the answer depends on the use case.
Yes, right, you are. But as a rule of thumb, if I tell you what to choose, what would you choose? Choose one.
Maybe S3.
Yes, go with S3 as a rule of thumb. Once you become comfortable and you understand differences, then start choosing the right storage solution for your deployment. What about security, network? What about that?
What is the question?
What will make your EMR faster in terms of network and security? Do you remember this slide?
Yeah.
S3,
I'm not reloading it.
S3
The
endpoint.
clusters in private subnet.
Yes, and the private subnet, because you want the traffic to go to the S3 bucket and not through the internet. And do you remember this scenario? When scaling out or a rebalance, this is a very expensive network operations, correct? And
Yeah.
this will impact your job performance. Everything goes to shit. So, as a rule of thumb, you want to avoid this by choosing which storage solution?
Maybe I'm also confused. Maybe I'm confusing it, but when we have the rebalancing, don't we get a big lag?
Yes, this is why it's a network bottleneck that lags your entire cluster because you're trying to move data around back and forth. And this job will become much slower because less machines can retrieve data for him.
Mhm.
So essentially, please.
Replication factor? Do you think that's matter?
What?
Replication factor. So how many copies you go?
Yes. A larger application factor, if you remember application factor, somewhere around here. In HDFS, it's 2. On S3, it's 3. So you have at least 3 disks in S3 that will be able to retrieve your data, or 3 partitions, which is cool, right? But what happens if you want to go faster than S3? What should I put here?
What if we do the HDFS replication as 3? Because by default, it will be 3.
Then, but what happens if you want to go faster? The number shouldn't be 3, it should be higher. You can do 5. You can do 7.
But it will increase the storage space, which will be a
Yes.
drawback.
But the question was about performance, not about cost. So it's a matter, in the end of the day, of a balance between these 3 components. And this is why essentially I put this framework here, because you need to balance between performance, cost, and maintenance. Performance, cost, and maintenance. So when I ask you about performance, you know what will impact that, but what would be the downfall of your design choice? Is that clear?
Yes.
Thank you. So what would make your EMR cheaper? Come on. It's an open discussion. Yes, you have the answer here, but don't open it. I mean, you can't open it.
Using smaller data types, like org and parquet, which and also compression.
Very good.
I can't
But
complete.
allow me to complete it for you. You want to be accurate on your storage format selection. For example, Parquet and Oak, and you want to apply compression settings to minimize footprint on your S3 buckets. Very good. So what would be the cheapest footprint? If you endured until this session, until this slide, the smallest footprint, what will be smaller than org? What will be smaller footprint than org?
Org than org, maybe.
Smaller footprint than org.
Maybe I can't remember.
What do you mean footprint? Sorry. So
for the size on disk.
So maybe text file and zip, right? gzip?
Yes. Text file and gzip. That would be your smallest footprint on S3. Yes? Smallest file size. Very good, guys.
But I have a question.
Please.
Normally, is the cost for S3 is it a big part of the overall cost? Or
yes.
compared to
No.
the
Wait.
the cluster.
Usually, the cheapest part of your job is the S3 because 1 terabyte costs about $20 a month, which is nothing compared with the compute, which may be up to a few $1,000s a month
Okay.
per terabyte. Okay? So, if you want to become an expert in cost reduction, here's an article from 2018 with 39 tips to reduce costs on EMR. You can read that in depth, really, but there's really no reason to go over this unless you want to become a true master. Okay? You can start with the basics you learned today and it should do the trick. So what would make your EMR simpler in terms of maintenance? Come on, you can do this.
Maybe connecting to S3 because it's simpler to manage instead of Hadoop.
Yes, because you want to avoid the scenario when you have a disk failure. And you want to be using, instead of core nodes, which type of nodes you want to be using?
Again?
If you want to become want to have a more simpler deployment, instead of core nodes, which node you want to be using?
Task nodes, okay.
Because there's no HDFS.
Yeah.
So if you lose a core node, you lose HDFS. But if you lose a task node, you lose nothing because the storage is here. Is this clear?
Yes.
Okay.
But
Okay, I have one question.
Please.
For the computation perspective, so if we put data on HDFS, which is local, right? The other way is to store it on S3. Is there significant difference between on the performance? So
Yes. Why? It will be much easier, but if you remember this slide, the penalty is round trip time because it's not local anymore.
So which means because I have had the issue that when I put the data on S3, it was a Spark, so it simply crashed. So the memory. So I think if we put the data on HDFS, it won't be a problem.
Because of the round trip time. If you configure your EMR correctly, you will have a very good performance at a very low cost and a very low maintenance. You need to know and understand exactly every different aspect of the EMR, exactly as I'm lecturing. From the basic concept of what is EMR, to the network and the security and the storage. Every aspect of this, if it's misconfigured, misaligned, or suffers from some sort of failure, will result in a crash in your HDFS job.
Okay, got it.
Okay, this is why I'm explaining EMR the way I do, because it will become very frustrating if you don't understand what you're doing with EMR. Okay?
Okay.
So guys, to wrap it up, essentially in the end of the day, data engineering is all about balancing between the three components we discussed: faster, cheaper, simpler. You want to have the best performance and the minimal cost and the minimal maintenance overhead. So if you want to do some more homework, I strongly advise to do the following homework about identity access management, just to create a temp user and give him a S3 read-only permissions, and create a role for EMR with least privileges, only the privileges you need to run your EMR jobs. Also design two types of cluster: transit cluster, a cluster that is running nightly for 4 jobs running nightly and are very intensive jobs, and design a 24/7 cluster running mostly 9 to 5 to a group of 10 analysts. And the last exercise, design a storage for a table. Design a storage layer for a machine sensor data on ETL input data. For example, year worth of JSON data on a bucket on AWS and that came through AWS Firehose. And another exercise, design a storage layer for medical data on ETL input data. For example, years worth of JSON data on a bucket. That would be it. To wrap it up, guys, we call to action, go to our, yes, please.
Yeah, I have one question. So what I've seen recently, like a lot of companies moving out of EMR.
Yes.
Even we used to deploy all the Spark jobs in the EMR, but we moved to Glue, and now I think the Glue is on the cost side. It's the same as like EMR as well, because underneath it is calling EMR, and now the solution that we got is the Databricks. The Databricks is kind of more cheaper than EMR, I guess. So so I just want to know like what is your thought on it?
You actually said it. Switching from EMR to Glue, I wouldn't recommend, even though if it's cheaper, because it will create a vendor lock. I would suggest keeping in mind all the different aspects of your EMR selection. You're probably doing something wrong if EMR is more expensive than Glue. I can pretty much guarantee it. That I can do cost reduction on EMR. I did one recently as last month for a customer. I reduced 70% of the monthly invoice simply because I applied methodologies that are right for his use case, because I have a very good understanding of what needs to be configured, how, and I have a very good understanding of his use case and the technology and how to reduce costs, improve performance, and minimize maintenance. However, going forward, regarding Databricks, you can always choose other distributions other than EMR, like Databricks, like Cloudera, and you can benchmark them as much as needed. The beauty about Databricks that it's cloud agnostic, meaning it runs both on AWS, Azure, and GCP, which is very convenient if you are in a hybrid cloud scenario, and you have to work on all 3 clouds. Databricks is very useful because it's very easy for data scientists. It has a very good ecosystem, and it has very good optimizations because it's a company by itself and not a company that has one feature called EMR.
Yeah.
Databricks has created a powerful distribution with powerful add-ons and powerful performance features. I want to be able to say which one is best for you without knowing
Yeah.
your use case in depth. But generally speaking, I can do a lot with both.
Mhm.
Meaning that it's not about which one is better, it's about what is your use case.
Mhm.
And you can do a lot with both of them. I would suggest this framework to analyze both technologies and compare that in depth. You'll be more than welcome to share your insights of this comparison in this community.
Sure.
Okay. Any
And,
more questions?
yeah, and one more thing. Let me compare Glue with the EMR. Because underneath it is calling the EMR cluster, right?
Yes.
So here I have one question, because in the Glue, if we need not a cluster that should run 24/7. It's just like a service. We are just executing our job and we are paying what we are using. But in the case that's true. It's totally depend upon our requirement as well. So if we do not need that cluster, in that case, I think Glue is better. But in the case when we need a job, when we need some job which is running, for example, streaming job, which we need to run 24/7, in that case, I think it is worth to go with the EMR. But what I've seen
They
that
are
there's a
valid.
lot of headache as well in the case of EMR. Uh, b- because earlier we had an infrastructure team which been maintaining the infrastructure of EMR kind of.
I would say that your thinking is right, but
Mhm.
not highly accurate.
Mhm.
I will give you one point to think about. When
Mhm.
you use a managed service, they
Yeah.
essentially fire up on-demand resources.
Yeah.
So essentially, you're paying the maximum of EMR pricing you could be paying. Because when you use Glue, you use it on demand. But when you use EMR, you
Mhm.
can use spot instances and essentially cost reduct your cluster
Mhm.
by an order of magnitude. Not
Mhm.
only that, you can fine tune your deployment in EMR to match exactly the resource type you need
Mhm.
to make it run as fast as possible at minimum cost. So you have
Yeah.
lots of flexibility, but the downside is that you need to manage it.
Yeah. Yeah.
So the question would be, if you use this framework, maintenance versus costs.
Yeah. Yeah, that's true. Yeah,
Okay.
that is the reason like most of the companies moving out of EMR because of the maintenance cost. And
But if you know what you're doing, the maintenance is kind of decreasing over time. Yes, Andre, please.
In this aspect, Databricks versus EMR, would it be? My understanding is that Databricks could use EMR under the hood as well.
No.
Correct me if wrong. Okay.
No. Databricks is something else. It's a different vendor, different. It would use EC2 machines, but it's
Yes.
another application entirely. Same Hadoop, not same Hadoop, same architecture of Hadoop. You understand? Same,
Yes.
HDFS and all that, resource management, yarn, but yeah, there are lots of different things there. Yes, please.
In this aspect, because cloud on AWS, it's pretty confusing, as you have shown. It's every option has 3 services and they are all maintained. anyway, moving aside from that, because you can go Databricks on GCP and it could be simpler. Would you say that Databricks for big data jobs would be easier to manage? Just the management part, because by the looks of it,
Compared to what?
Compared to
EMR?
AWS EMR, yeah.
Yes.
Just management part. I'm not saying faster, cheaper,
Yes.
probably simpler
Yes.
on the management side.
Yes. Unfortunately, there's no one that will tell you otherwise. It will be much easier to maintain a Databricks cluster compared to EMR.
Okay, would you say
Significantly.
they will lock you in? Say at a point in time, you'll say want to move from Delta Lake on the way your file format to something else. Would you have a hard time for that?
If you know what you're doing, no. It will be easy.
Thank you very much. That answered my question.
Just out of curiosity, what's the use case?
Well, the use case was, because I'm not with the company anymore, a bunch of data scientists, they were starting to run jobs. I was the only data engineer against about 5 or actually more 10 data scientists, and I had a hard time to understand which one I'm going to choose. Definitely EMR and the complexity of it, even if I'm AWS architect. I don't know the whole plethora of architecture in AWS, by the way, but it made me choose or start looking into Databricks just because of one to many in terms of data engineering against data scientists. It seems a bit simpler. But then people came on top and he said, look, Databricks can be incredibly expensive as well if you forget the machines running, how much power you give to your scientists if they don't know what to do. So
no, here's the thing you should know. It doesn't matter which technology you use, there's always a dark side. There's always a downside. There's always something that will not work well unless you do something. It's true for any technology. But you need to focus on the benefits of each technology and the terms of your use case and to match them together. If the match is high, then manage your downside and the dark side accordingly.
Yep.
The beauty, allow me just to finish, the beauty of this architecture framework, the faster, cheaper, simpler, is that you cannot balance the entire tree all the time. Usually, if you're doing something well, you manage to balance 2 out of 3. For example,
yes, totally.
Performance and cost, but not maintenance, or the other way around. Okay? So somewhere you need to pay the price, either in billing at the end of the month, or in performance, or in maintenance.
Yes, totally agree with that. Thank you very much for your answer. I might have another question later down the line. Thank you.
Sure, and the next time you get into a scenario when you need to decide, just contact me. I'm here. That's my day job. So, Ronnie, please.
Hi, do you hear me? Hello?
Do I have what?
Do you hear me?
Yes.
Yeah, okay. I wanted to ask about the Databricks versus EMR from another angle. I mean, I work with Databricks and I don't really like working with notebooks. So
What do you don't like?
Scripting versus ID, PyCharm.
What you don't like?
I mean, I prefer to write the script notebooks.
Mm-hmm. Yes.
Hello?
Yes, I can hear you.
I prefer not to work with notebooks, but to work with scripts to write models and functions, and it's easier for me. And I used to work on the on-prem with Cloudera when I was using Spark. And I was wondering whether for people who don't really like work with Databricks notebooks, whether you would still say that it's easier to work on Databricks versus EMR. I mean, is EMR that complex to set up that you need to go to Databricks, or is it relatively straightforward? I mean, assuming that I'm doing all the security groups and all the setup that you just mentioned today.
Listen, just a full disclosure, for the recording and for people on board here. I don't get any benefit either from Databricks or AWS or GCP or anyone. I'm a consultant. This is what I do for fun. So what I say is purely what I think. But usually, I put a disclaimer around it. It seems like in your use case, you feel comfortable with playing with scripts and configuration and network and security. So it's not a hassle for you. The same way it would be in my use case. It's not a hassle for me to manage an EMR.
Okay.
But for someone who doesn't know Hadoop at all and it's his first time, EMR would be a terrible nightmare.
I understand. Okay.
But in the end of the day, if you're switching between, as you said, from Cloudera data center to a cloud, and you're comfortable around scripts and network and security, it's basic trivial stuff for you, then EMR is a very good tool.
Okay.
I'm not teaching EMR because I hate it.
Yeah, I understand. I'm just saying that if people, I mean, I like Databricks as well. Just saying that people should, I think, consider also the fact that it's using notebooks and it has many advantages, but notebooks have also disadvantages. As there's long discussion in machine learning data science around using notebooks regardless of Databricks, even about Jupyter notebooks versus scripting. So I think it's also something to consider, that you're kind of being locked working with notebooks, and it has its own disadvantages that people, I think.
So
if
according
is not that complicated, then I think people should consider it as well. That's my experience.
So according to me, it is like all this notebook and all this feature in the Databricks is based on the role, what role you are playing. For example, if you're a data scientist, or if, for example, you're the data engineer only. In that case, sometimes you need to check the data because there are some situation where we cannot look the data, the production data, for example. So we do not have permission. So through all this notebook, you can view the schema inside it, what is happening inside it. So how this transformation is doing. Even you can perform your testing inside the notebook. But truly speaking, even in the development point of view, I like the development, like building jar and deploying jar in the Databricks. But if you're talking about notebooks, I think it is a cool feature. It's depend upon your need. Because whenever you need it, because there may be some situation where you have to use it, maybe because for me there is situation like I cannot access a data from production, and even the size of the data is very huge, and even I cannot view through S3. So because of that, what I did, I just use a notebook and just I read all the schema and whatever inside it. So for me, it became like to understand about the data is became more easier as you know it was very difficult to download all the files inside my local machine, all the Parquet file, and again viewing all the Parquet file local. So it is better like if the data is in S3, you can look at the notebook.
Okay, great.
Okay, guys, any more questions? Now is the time. Going once. The hands are up, but nobody's talking. So
Sorry, it's Andre again. First of all,
Sure.
thank you for the whole presentation. It's very useful. And for sure, I will be digging into the resources. Now, second of all, it's about the complexity. And do you have, I'm not asking hacks, do you prefer to use tools like monitoring tools to manage all in one,
always.
or you just
always.
Is it
Always.
data? I'm not throwing things. I'm not paid. I was just using some, and then switching to the others, but it's the space is so vast that it's so fragmented that it's a waste of time to configure one and move to the other and move to the other, unless you have a huge team of people to analyze the sides and the downsides, or you have the time.
So
Would you recommend some?
I had the pleasure of working with all of them because the nature of my job. I'm an architect. In each company I switched, I was given the opportunity to examine everything before I decide. So I was lucky in a sense.
Mm-hmm.
But it's not always the case. But you should know that sometimes you can hire an expert for like me for a couple of days, who will evaluate your use case and give you a recommendation.
Yeah, I
I'm
think
not trying
that's
to
it.
sell my services.
No, I totally understand.
Generally speaking.
Yes, previous company were cheap on everything. That's why they had one data engineer to 10 data scientists, and they didn't understand what was going on. So,
but still, you can tell them something. Listen, even if especially when you are one data engineer scenario, you can tell them, listen, our infrastructure costs $10,000 a month, for example. If we bring an architect and we pay him even $2,000 per one day, I wish, but let's say, in 2 days, you'll pay $4,000, but maybe you will save 50% of our workload every month. So that's 12 times 5, that's $60,000 by paying $4,000 for an outside consult. So why not do that?
yeah,
That's insane.
I'm totally with you.
Especially if you're in a growing startup scenario where cost of your monthly invoice is rapidly growing. You understand? So you can talk about these issues. I know it's very easy to convince management to talk to an expert like me. I understand. And I know there's not always time. But generally speaking, if you want to become an architect one day, you should push for comparisons, benchmarkings.
Yeah. Well, I'll give you a straight example. I don't know if you must
Please.
know Airflow versus Astronomer. And I said, for
Yes,
us guys,
I
you
do.
put managed Airflow on AWS, which I raised for them. I didn't even know it went into production until they ran into something. And it's if you put for 4 environments, 2 tests and 2 productions for various teams, you will end up with $20,000, isn't it? At least. And it also depends on the run, according to my cost, to my zone, which is mainly Europe, London, and so on. And I told them, look, comparison, and I had really a lot of talks with Astronomer, which is a managed Airflow, and you will only pay by DAG that's successfully executed, and very good support. No maintenance, no MWAs, no infrastructure, or maybe some infrastructure. It was $20,000. So it would be on par.
$20,000. Wait, but $20,000 for which period of time?
Per year. Per year, and this is like for like. Per year, I was discussing, and they've done the same comparison. And so they said, no, we can't fork a bill straight up with $20,000. I said, look, it's going to save us at least a data engineer plus, which is how much it is. They are not cheap, by the way. And they will save you XYZ time because you don't manage MWAs. You don't have problems with permissions or boarding users, IAM and so on and so forth. No, we can't. We're going to go. And eventually they went with MWA based on the POC I've made, and then they scale it up to 4. So I disagree with this. So yes, different companies.
And they eventually paid up a lot more, correct?
Yeah, they usually will start to pay up in the sense of 50% more, 50, that's not 15.
Yes.
And on top of that, they will have a legacy to maintain. I don't even know if they will ever hit the mark of 20,000 DAG runs per year in the first years. Not to mention that these guys will manage you and get you incredible support and so on. So at a point in time, it will become more expensive. But for now, for a couple of years, it would be way cheaper unless you have a data engineer to manage all of that. It's, even
so
if you say...
Allow me to say something. I understand. But the way I see it, it falls on you as a data engineer to become so expert in what you do that you will not use Astronomer nor MWAA. You will use your own Airflow installation and
Yep.
your own management. So the first 2 years will be difficult because you need to learn Airflow inside out. And you have lots of Airflow knowledge in our community. Lots, I mean, like a gazillion amount of knowledge. And I talk so much about Airflow, it will blow your brains out. But essentially, you have how-to examples, you have installation examples, you have meetups in English and in Hebrew, you have best practices for performance tuning of Airflow to reduce your cost. I can talk about impressive amount of performance that will blow your mind. But in order to do that, you need to be willing and able to understand all the different aspects of every technology you touch. For example, in EMR, network security, identity access management, S3 HDFS, compute instances configuration, Spark configuration, performance tuning of everything. And then the same thing applies for Airflow. Network security, operational database, file system even, the EC2 type you are choosing, the Airflow configuration, the Airflow architecture. And there's many things to know, but the way I see it, your job as a data engineer is to master all that. That's your job. I'm not blaming you or anything. I'm just saying there is always going to be a scenario, it will be understaffed, under-budgeted, too much jobs to do, and lots of other challenges. But in the end of the day, that's my job and your job to make sure everything runs faster, cheaper, simpler. Well, at least that's the way I see it. I hope this is helpful.
It definitely is. It definitely is.
And we can talk about Airflow if you like in other sessions. There's lots of recordings and you can contact me directly. Just shoot me an email sometimes with your questions. And my email is right here on the summary. Where's the email? There's LinkedIn, and I will put my email here as well. You can screenshot it for now that you won't lose it. Whatever you do, don't contact me on the Meetup messaging board. It's terrible. I get it in delays of months sometimes. So this is my personal cell phone, my LinkedIn, my email. Just shoot me an email, free of charge. I'm not charging for community questions. It's just, that we keep in touch and we help each other. And furthermore, if you're doing something interesting, benchmark, or you learn something and you want to blog about it, you're more than welcome to publish it in our website. I will be honored. If it's something the community will benefit, it's just for fun. There's no commercial thing behind it. So there's no commercial motivation behind it. So you're more than welcome to share any type of knowledge you have regarding data. Same goes for you, Ronnie. If you want to talk about data science or something. Okay?
Yes. Thank you.
My job here in this community is to share my knowledge, but I'm trying to encourage you guys to share your knowledge. If you stayed until this session, slide 100 in part number 2 of a very long series of lectures, you heard me talk about fine-tune 401 configurations. That means you're experts. and you're interested and you want to broaden your mind in this type of technologies and domain systems and architectures, and you want to take it to the next level, so start doing so. Compare technologies, write in a blog, share it with me. I would be honored to put it on my website. And I will be honored to comment and to learn even something new. There's no way I know everything. There's really no way. The amount of technologies, as mentioned before, is too fragmented, ever-changing, lots of options, lots of configurations, lots of billing options, and there's always too much work to do everything by the book. So, and AWS expects you because it's in the cloud, it's demystified. You can do everything because it's simple. Look about this slide. This slide is mostly EMR technologies that are replaced with only one logo. The EMR logo. Where's the EMR logo? It's like 40 technologies of open source hidden behind one logo. Man, it's insane to master it. You know, they took the solution architect and made a specialization around data called big data solution architect, and his sole job is to master EMR. You know how many big data solution architects there are in AWS? One per country at best. So you'll probably never get access to them as an EMR client or AWS client, because only the big ones get those, because it's very complex. Not a lot of people want to master it. A lot of people want to master it, are interested in mastering it because it's insane. In the past, when I learned EMR, even Hadoop, I started with data center Hadoop. I started by downloading Hadoop open source, deploying it, configuring it before using Cloudera and before using EMR on the cloud. When I mentioned that, the fellow architect, he said something that I will never forget. Omid, are you insane? Nobody does that. They all buy distribution, like Cloudera, Hortonworks at the time, Databricks, all run to the cloud. Nowadays, you never do that. You never manage your own Hadoop distribution. Open source. So the same thing I did with Airflow. Nobody dares to manage Airflow by themselves. Nobody. This is partly why I have a job, because everybody they use Airflow eventually hire my services because they ran into performance problem, cost problem, and maintenance problems. And the most complex use case I had in Airflow was 2 years ago. A customer that hired me for 6 months to stabilize the production, staging, and QA environment of Airflow. It was highly unstable. Every 3 hours, it kept failing. 3 hours. You can imagine a scenario where your data pipelines fail every 3 hours around the clock because you don't know Airflow, because you didn't choose to manage Airflow, because you chose Airflow and it probably implement all the worst possible practices you can do in Airflow. So the same goes for Hadoop. I shared in this community a use case where a company came to lecture about their use case. They had 2.5 petabytes worth of data, and they used Hadoop on data centers, and they were highly cost effective. They spent $500,000 per year and a team of 30 people to manage it. And they talked 2 hours in this meetup about their transition to another SQL solution, licensed, mind you, managed, and they've paid, get this, $4 million a year instead of $500,000, and they were happy, very happy to pay the price because it saved them. Which part of the triangle? Would you like to guess? Because we know it's not going to be cheap.
Can I guess? Faster, simpler.
Which one is going to be?
I choose faster.
Simpler.
But how about the price of the engineers?
Reduced because they could cut down their team by 50%.
So it might be a bit cheaper as well. So it's not exactly 4 million. It could be less, isn't it? And if it's in US, it might be even cheaper because the cost of an engineer is significant.
Let's put it this way. In a company with such a challenge, I bet the engineering team is happy because then now they can practice the good, interesting stuff like processing the data, getting insights, doing more with the data, and not focusing on maintaining clusters.
Can I ask you and tell you something? I'm working as a consultant. I'm in the analytics space, mainly on the structure side, and there's new tools on the block, and the company is big, very big, and so on. And it needs to qualify at enterprise level, hundreds of users. And there aren't tools that are managed that could be served as an enterprise. So the only way to do that is to do more costs, but long term, because they implement this on analytics side, and I can throw in there Snowflake and some other tools. It's going to be better for them because everyone will have access to the data. And if some decent amount is managed, not all of it, not the best, they will harness the data a lot better and faster rather than having AWS, EMR. I'm not saying it's bad or good for us as data engineers. What else? A Redshift, which needs to be managed. So they're moving from Redshift to, you could say, like for like with Snowflake. But I think as an analytics engineer, to put the data to use, it is more profitable for them to do that. So they have higher costs on one side, but a lot more benefits on another.
So allow me to focus what you said. You're saying, forget Snowflake for as an example. You're saying a SQL analytics solution, in the end of the day, will outweigh the cost because it will make the data more usable and accessible throughout the company. This is why I'm an SQL advocate. And this is
I'm
why
the same. I am SQL all over. Yeah. And just
But
not to mention, okay, all of that, sorry to interrupt. You are focusing that the skill barrier to enter the data, to start analyzing it, it's a lot lower. You need to know a bit of SQL, maybe a bit of Python, and that's it.
Yes.
While with data engineering, it's managing architects, cloud, Python, Unix, Bash, what else? So this, I think this is the trend to go if you can afford it. If not, you have to start somewhere, I don't know where.
And this is the second focus I will put on your comment. In the end of the day, I will ask you, what is the use case? Maybe it will worth your time to use EMR. Maybe it will worth your time to use something else entirely. Not Snowflake, maybe something else. Maybe Snowflake, I don't know. What's your use case? Okay, the job of the architect is the balance between the business use case and the selected technology. That's it. Any other questions, guys, before we wrap up? I would like to thank you all very, very, very much for bearing with me, saying until the end. I know it was hard and non-trivial to follow. And thank you very much. And we'll meet on the third session on the 28th. Okay, good day.